Hi, welcome to Weekend Project with StoneZ56. Today, I would like to show you how to easily OTA on ESP8266 with an AsyncElegantOTA library. Here's the tutorial summary. I will briefly explain what's OTA and why, and where to download AsyncElegantOTA library, how to access ESP8266 from browser through Wi-Fi, where to find .bin file to OTA. Next, I will show you how to update firmware through browser. If you have tried Arduino BasicOTA, you know it's not easy. At least for me, I never get it to work. So let's get started. Why do you need OTA? Let's say you have built an ESP8266 project. Install it on top of your roof. It'll be very troublesome to update firmware, right? OTA stands for over the air. Update ESP8266 firmware through browser via the air over Wi-Fi. Let's say you modify a few parameters or updated firmware to a new version. This is very convenient, isn't it? Alright, let's begin the tutorial. First, open Visual Studio Code IDE. Once it's opened, and press F1 to access Arduino Library Manager. In the search window, just type AsyncElegantOTA and hit enter to search. Right, this is the library I'm looking for. Click install. Since I have installed this library previously, I will not do it again here. After install the library, you will need two extra libraries for OTA to work. They are all on GitHub. This is AsyncElegantOTA I've downloaded. I also mentioned extra libraries needed for OTA to work properly. They are ESPAsyncWebServer and ESPAsyncTCP. I will leave the link in the description below, as well as the direct download URL. Let's go back to our code. I'm using a Node MCU with ESP8266 chipset. If you were using Arduino Nano or Arduino Uno, then you cannot OTA to these boards, since they have very limited flash memory size. I recommend using boards with Wi-Fi capability. I have assigned file system 2 MB and OTA for 1 MB on the configuration for my Node MCU. Of course, ESP32 is also capable of OTA, but we need to use a different library. I will enlist ESP32 library needed for OTA in the description below. The extra libraries we have downloaded are zip files. Unzip those files and place them on the library of your Arduino project folder. See, I have placed ESPAsyncTCP master and ESPAsyncWebServer master here under the library folders, so they can be found during the compile time. Let's go back to the code. Here's AsyncElegantOTA sample code for ESP8266. I have copied to the editor. The code is very simple. First, change the SSID and password in the sample code to fit your environment for it to work properly. Okay, after that, let's upload the sample sketch to ESP8266. Here, I've connected the LCD panel to ESP8266. Let's upload the sample sketch by click the icon. In VS Code, the upload icon is located on top right corner. The sketch is already uploaded. Open the serial port monitor to check the status. It shows we have connected to Wi-Fi and IP address assigned. The IP address is 192.168.0.122 and the HTTP server has started. Nice! Successful at the first try. Let's open the browser. Type the IP address 192.168.0.122 and hit enter. You can see the browser shows, "Hi, I'm ESP8266. Let's check the code on line 30. It tells the browser to show, "Hi, I'm ESP8266 if someone accesses this chipset from browser." Great, you have successfully accessed ESP8266. But how do you update the firmware? Just type /update after IP address to access the firmware update page. Select firmware and ESP8266. Click the button Open Select File to select the bin file. But where to find the bin files? If you are using VS Code, the bin file can be found in the build folder above the project folder where we selected in VS Code. Each time you compile or upload, the bin file is generated here in this location. If you are using Arduino IDE, you have to create your own binary files. Click Sketch, Export Compile Library from the menu. Arduino IDE will start to compile a bin file for you. By the way, I really recommend use VS Code to replace Arduino IDE. It's a really good IDE tool. Okay, the bin file is generated. Let's check where the bin file is. It's under the Arduino project folder. See, the ntp time library 2.ino.generic.bin is generated here. I'm about to upload the motor feeder OTA ino.bin file. Let's take a look at the motor feeder OTA sketch to see what's inside. Motor feeder OTA is an ongoing project, but it currently only connects to LCD. As the code started, it will show ESP8266 firmware uploaded successfully. It's more convenient to have the LCD to display the IP address or either the firmware is updated or not. While firmware is updating, you can see the progress bar on the browser. It's quite fast to upload the sketch with Wi-Fi. Okay, the firmware is updated successfully. Look at that LCD. It shows ESP8266 firmware updated successfully. That's why I like to connect LCD to IoT project, so I can see if the firmware is updated or not remotely. See, AsyncElegantOTA library is so easy to use, right? Next time, I will show you how to merge AsyncElegantOTA with a working ESP8266 project. So your ESP8266 project can be OTA updated with a browser. That's all for today. Thank you for watching. If you like this video tutorial, please share, like, and subscribe. I will see you next time.